Okay, let's get started. Thank you for joining us today at the University of Washington Data Science Seminar. It is our last seminar of the quarter. I hope you had a good Thanksgiving, and I wish you good luck on your exams already. I know that you'll have a lot in front of you next week and the week after. So to kind of wrap up our seminar series today, we're going to be hearing from the Scientific Software Engineering Center at the eScience Institute, or SSEC. The center works with researchers across various fields to build robust open source software that advances inquiry and fosters community. These reusable tools infused with industry best practices accelerate research and sustain discovery beyond the initial SX involvement in the projects. It is my pleasure to introduce Anshul Tambe, the Technical Program Manager of SX, who will be introducing our speakers for today, and we'll talk more about the center. Thank you so much. Looking forward to it, and welcome.
Thank you, Nicoletta. We're excited to be here as a center. SSEC, as Nicoletta mentioned, is housed in the eScience Institute across the courtyard. We're funded by Schmidt Sciences, which is a philanthropic organization. And our motto is that we source projects through Schmidt as well as through UW to build open source software in 6 to 8 month engagements. And they span a variety of disciplines, 2 of which you'll interact with today. And I'm really excited to introduce 2 of our engineers, Don and Cordero, who are senior research software engineers with us, claiming experience both from academic software engineering, startups, and a variety of different expertise between the 2 of them. They'll be covering first a project called Offshore Geodesy, which is based with researchers here at UW, and another in education and kind of training educators, which is based in an organization at UW called Cultivate Learning. So I'll turn it over to Don to get it started, and we appreciate you being here.
All right. Thank you all for joining us today. So we'll get started. Today I'm going to talk about Offshore Geodesy. Is one of the projects that we worked on over the past last year. And this project involves basically it's advancing research and collaboration in seafloor deformation. How many of you guys are familiar with the term geodesy? Okay, very few actually. Geodesy is just the study of essentially the shape of the earth, right? And so what do we do here? As software engineers in this project. Well, let me just give you a rundown of the background. Let me see why is there we go. So this project have a research goal of this project is observing long-term horizontal and short-term vertical deformations in subduction tectonic environments. So what does that mean? I'm sure most of you know about, the big one that's coming. And there's this thing called the Cascadia subduction zone off of the coast of Washington that we should be aware and be afraid about. Well, essentially this project measures how fast those plates are moving. So here's just a little graphic of what that looks like. So what you can see there is a subduction oceanic plate, just the Pacific Ocean plate, with the continental plate, which is your North American plate. And so what they're trying to do is measure the movement of that plate by using this really cool technology that is essentially uses a multi-tiered GPS system. So I don't know if you guys know this, but GPS doesn't really work underwater, right? Those satellite just doesn't penetrate water very well. And these plates are really deep. And so they do that by using this basically this multi-tiered system where you have a sonar transponder on the seafloor, it's attached there. And then you have what's called this wave glider, just like essentially a really smart robot that just float around in the sea surface. And then that wave glider communicates to the satellite, and that's how you know kind of like the GPS position. And so the challenge here is that these researchers are trying to essentially calculate what is the exact position of those sonar transponder to like a centimeter level because we want to kind of measure what is that rate of movement of the plates. And so they do this essentially by using this software that has been around for 25 years. And before this talk, have you guys heard anything about this sort of technology before? No, exactly. Right. Because the problem here is that this technology has been developed by a singular scientist for 25 years, and it was written in Fortran 77. And so they were able to, develop this really cool algorithm to calculate all of that, combine all the data from GPS, from Waveglider, and then also the transponder and things like that, and find the exact location of that transponder. And I'll talk through sort of what that looks like. And yeah, so this software is hard to understand, hard to use, maintain, and extend. And so the first time that I got this project, I was talking to the postdoc, and they're like, yeah, nobody wants to touch this. Every time I email it to somebody, it's like, oh, never mind, I don't want to touch it. You run the thing for me, please. So that's a problem, right? And here's just a look at sort of what that system looks like. So this is just the software is made up of shell scripts and Fortran software, Fortran code, as I mentioned. And this was me going through every single shell script and trying to figure out how does this all connect, what the heck is happening with the pre-processing workflow, and then the actual processing algorithm that calculates that position of the transponder. So you can see it's very messy and very complex. And yet again, this is 25 years of work here. And so let's just condense that down and give you a sense of what I worked on here. So you can see in the black squares are just proprietary software that we didn't touch at all. And these black squares are manufacturer software that process very raw data that's coming from the sensor. And then it gets passed through this orange software. This is the pre-processing. So as I mentioned earlier, it's multi-tiered. So you have data coming in from like a GPS location data at sampling at a certain rate. And then you have the Waveglider data that is measuring kind of how the Waveglider is, yaw, tilt, and things like that. And also, the speed of the Waveglider, and then it's collecting like the sound speed and things like that. So that's also sampled at a certain rate. And then you have what's called the transducer, which is at the bottom of the Waveglider pinging to this transponder. And so then you're like collecting, okay, ping, what time is it sent the ping? What time did I get the signal back? So that's also a sampling at a different sampling rate. And so the pre-processing workflow essentially combines all those different sampling rates and then figure out, what is a common, timestamp for all those data. And that process, is called, we use what's called a Kalman filtering. And later on, you'll see what that looks like. But then after that pre-processing happens, then it gets passed into this, it's called SFG solve. So this is a solving for that location of the transponder from all this data. And this is kind of the algorithm that has been developed for 25 years. And yeah, it was all written in Fortran. It was very confusing. And mind you, I did not know any Fortran coming to this project. So has been a very interesting project, to say otherwise. But what is this solution? Yes.
You bought SQL, or that's acoustic, right?
Yes, that is acoustic. It's collecting like time sent, reply time, things like that. And then exactly like the location of the Waveglider. And so you have to do like a triangulation calculation thing. And then you have like the positioning of the Waveglider. So like all these data processing has to happen to figure out exactly the position of the transponder at a certain timestamp.
The water column?
Repeat the question.
Oh, the question was is the transponder using ping, what's it called? Acoustic, sorry. Yes, acoustic. And it does collect, so like it does collect sound speed, like you have to have sound speed profile to do that kind of calibration to figure out the location and stuff. Yeah, so there's data there that needs to be inputted in. And I think I kind of show that, maybe not. No, not on this one. But so yeah, so the software solution was we developed a Python library to essentially, we ported all the code from Fortran to Python so that we can extend the community and people can start playing around with this algorithm. And then I know that like a lot of the collaborators within that community are like, hey, I come up with a new, even better algorithm to do this calculation and things like that, but they don't know how to contribute because it was in Fortran but then they're, everyone's familiar with Python these days, especially for data science. So yeah, and so here's just kind of like, here's a look of the read the docs for that software, but I'd like to highlight this Fortran benchmark. So like, you may wonder how did I make sure that I ported all this code correctly? Well, we did benchmark it with the running Fortran and making sure that we, the results are exactly what we're expecting after porting those code over. Actually, through this work, we found that there was a bug in the Fortran code where common filtering, there's like a whole equation. The Fortran code is missing a variable within that equation, which throws off all of the like actual results. So now we're like, oh, that's not good because there's been research papers coming out and that results are not good and you can't really reproduce those, right? So yeah. And what are the technologies I used to do this? Well, I think everybody's kind of familiar with pandas. Use pandas to merge tables together. And then, this process can, I think earlier I show like 300 gigabytes per day. And so there needs to be some sort of scalable way to do this. And so I read in all the data with pandas, typical thing, and then convert that to NumPy. And why did I convert it to NumPy? Well, one of the process for this kind of common filtering is going through each individual data point and essentially doing some sort of like, interpolation and filtering. And so that can be really slow because you have to kind of do a serial computation rather than, your typical vectorized NumPy computation like parallel compute or anything like that. So in order to speed that up, I actually use a Numba. How many of you have used Numba? Oh, okay. Do you know what Numba is? No. All right. Cool. Got an audience that doesn't know Numba. Well, Numba is a just-in-time compiler in Python, and so that just-in-time compiler just means it will compile your code on the fly so that it can be basically computation can run faster. And so we use Numba heavily so that it can run close to the Fortran speed, if not faster. And the resulting of this is like we did have a faster speed than Fortran by about like 30% speed increase than the Fortran one. But here's kind of what that looks like, right? Again, I said it's a very serial computation. And so there's a lot of for loop. And so with Numba, you can just live with your for loop. So if you have really bad for loop code or code that is very serial, just throw Numba at it. Very simple. You just put in the decorator Numba and JIT, and it will just in time compile for you. And just a fun fact for everyone, that Python 3.13 actually have now an experimental just-in-time compiler built in. And so you can start trying that out and stuff like that, see the documentation for Python. But yeah, it's definitely a way to speed up your code quite a bit. And then now you can see here kind of what that code looks like now. Like I could use Jupyter Notebook to run my whole processing workflow and then input my configuration YAML file and this. And so like there's a lot of ease now to actually running the software and importing and then extending that. Now it's in Python using basically a very typical data science tools. And so what is the impact of this? Well, from this work, they started creating a data standard for their data. And that way, then, this processing can be interoperable across their different teams. Actually, their teams are made up of very many different agencies. And later I'll show you in the map kind of what are all the different agencies there. But and as I mentioned, 30% speed up. And then now we've handed over to the UW group. And so the UW group is actually working with a group in Canada to expand the software, maintain it. And and as you see earlier, the documentation. And now they're actually in the process of writing a paper about it, which is really cool. And and this is just a view of kind of what that data standard looked like. We were actually able to integrate the data standard. And I use Pydantic here. Pydantic is a data validation library, and my colleague Cordero will talk about that a little bit more than me here. But essentially, I just defined their data standard here with what is their column names, what are the types, and what description about it, so that you can you get validated for that data. It is truly a global impact. The geodesy community, the seafloor geodesy specifically, is pretty small, but they span multiple agencies across the world. So we got to work with people from Canada, with Ocean Networks Canada, UW, the international, I think Paris for planetary physics, or something like that, Center for Planetary Physics, and then Japan Coast Guard. And that thing on the red I'm just highlighting is that they updated actually their standard to be able to read in YAML file, YAML config file after conversing with us during this time, which is really cool that we're able to make that impact within their community. And so, I just wanted to thank all our core contributors here, myself, the postdoc here at the UW Earth Space Sciences, John, and then our colleague at ONC for helping validating the data, making sure, we're reporting things correctly. And then the common filter algorithm was from him. And so, and our grad scholar Madhav that has contributed a lot of the code. And with that, I'd like to thank you all again. And do you have any questions? Question?
Yes, so I have a question about the JIT parts.
Yes.
Nice. So you don't want to run the JIT for the pandas operations, right?
No, you don't run the JIT for the pandas operation,
Another question related. Have you considered swapping out pandas for polars or something else?
That's a yes, I actually have. Polars would be a lot, probably would speed up even more this package. We definitely considered that. However, since our engagement was very short, we didn't okay, let's not rewrite things into polars just yet. So that's where we are.
I remember correctly, NumPy could compile to a GPU, right?
I don't remember on that one. Not necessarily though. You might want to check their documentation on that one. Cool.
If you're interested in contributing the polars changes, it is an open source library, and they're here on campus, and they'd be really interested to take collaborators of that sort as well.
Yeah, thanks for the questions. And I'll take it over to Cordero.
Questions? Excellent. Now we're gonna switch to Cordero.
Yeah.
All right. First of all, can everyone hear me? Good. Okay. So today I'm going to be talking about the CECI database, modernizing for scale. And so we're going to follow a similar format to what we had from my colleague Don, starting out with research goals and domain, proceeding into software problems, software solutions, and then broader impact. So first, getting a little bit into the research goals and domain. This is a project that comes out of the education department here, specifically out of Cultivate Learning. And so what I want to do is give you a little bit of insight into it, because I would imagine probably how many education people are in here? One. Okay, there we go. All right, so this is going to be specifically early childhood education. All right. And so first, the coaching and educator community interface, or CECI. I'm going to interchange that with Coaching Companion throughout the presentation, so the two are the same, right? And so it provides tools and resources to support the professional growth of early childhood educators. All right. So the reason why this is important is because there's a field that's kind of like grown, known as practice-based coaching, or PBC. And this is important because what it allows is it helps to foster positive changes in educators through coaching experiences. And this allows them to grow through collaborative partnerships, shared goals, focused observation, and reflective feedback, right? So think of it as you have, coaches who are right there, older, possibly more seasoned educators, those who may come from a different background than you, that just help you to coach and understand, like, where do you come from? Where does your classroom come from, right? And so the way that the platform works is that first it works on facilitating collaboration, all right? So this is going to be in the form of video conferencing, discussion groups, just that kind of interaction, right, between yourself and your coach. Next, it also offers resources. So let's say that your coach says, hey, here's a really good video to help you with what you're looking for. Or, hey, this is an observation that I had during my classroom. Let me share that with you, right? So this is where this particular piece comes in. So it allows you to share video resources, materials, anything of that nature. Next, it also supports goal setting. So in the course of education, you have a classroom, you want to teach your students, you have goals for where do you want them to be? What do you want your classroom to look like after this, right? And so it helps you to have someone who's right there with you to actually help track, what does that look like? Are you actually effectively implementing all of these different things that you're trying to do? And then finally, it provides accessibility, because since it's a web platform, available anytime, anywhere, right? So you don't have to be in the same location as your coach in order to receive some excellent guidance. So the reason that this matters is, first of all, it supports educators, right? So it provides teachers with professional development opportunities, with someone who can come in there and to help them by empowering them in the kind of tools and resources available, as well as it enhances the coaching relationships, right? Because once again, it's not just someone who has to be in your area. This could be a coach somewhere else, but they have just what you need. And by training up our educators, that improves the outcomes for the kids. And that's really what it's all about, right? And so it really, this training helps with teachers being able to really assist and implement the things that are necessary for social emotional, as well as socioeconomic and cultural differences, right? So you're able to meet those needs that the students have. Next, you have advanced early learning systems. And so Cultivate Learning and the Coaching Companion platform is not just in the state of Washington. So we do use it here, but it's actually available for any state, and it's able to be modified to meet the regulations that are available anywhere, right? So it's really revolutionary because it also is a nationwide program. And then finally, equity and inclusion, right? So you're helping these teachers to understand where they come from, where their students come from, what kind of learning needs do they have, how can you meet all of those things? And then it helps you to have a more inclusive classroom, which is ultimately going to benefit the students in the end. All right, so we have a decent understanding of kind of the background of what we're working with. So now we want to take a look at the software problem. And kind of the short of it is, we're working on databases. Seeing that the title is about databases, probably would figure that, right? So in order to get started, let's do some really simple database basics, all right? So we have relational and non-relational, which most people are fairly familiar that Both exist. In this particular presentation, we're primarily going to be looking at relational databases. But the reason I wanted to present this to you as well is because the problem that we have actually comes because it's not a strictly relational database that we were working with. It was a relational database plus key values and key value pairs. All right. It's just key value pairs. Like what kind of harm can it cause, right? But what you'll see is that as you look downstream, there actually are huge impacts on the final outcome once you change the database by just this small amount. All right, so let's see what this looks like. So first of all, everyone meet Kyle. He is going to be the maintainer for the Coaching Companion package. And he's been tasked with adding a new feature that that's going to be automated reports for institutions, right? Simple task, should be able to be done in a pretty short amount of time. So in order to do these and compile these reports, he has to compile data, right? So you have these reports, you need data for it in order to do that. So you're looking coaching sessions, educator progress, so on and so forth, right? All these different pieces of data that you have inside of your database. And so in order to do that, he has to pull data from multiple tables. Very straightforward, just what you would expect, right? Well, because of the fact that the database has these key value pairs, here's where the problem comes, right? So by key value pairs, what we mean is, imagine that you have a single key that's a component of something that's in the UI, right? Well, it's going to have a value associated with it. Well, the value there could be a key to another set of values. And then don't forget, there are other keys that will be values that are needed from other keys, right? So it very quickly becomes kind of an intertwined kind of problem. So if you've ever, think of like earpods, right? You get the cord, it's in your pocket, it's jumbled up, it's all interconnected, okay? So actually unwinding this becomes very hard because what we end up having is these hierarchical data lists because you have keys that are values that are dependent on other keys that are dependent on other values. And so as a result, you end up with very long, complex queries, increased execution time, and inconsistent pipelines, okay? So even worse is the fact that if you want to add in any new feature, what you've got to do is you've got to write these things called recipes, which is saying, okay, I really can't use anything that's there. I have to basically follow down all the way through these trees. What is the hierarchy of values and the keys that are associated with them in order to get back the information I need to then build out the feature that I need, right? So it's completely unusable, anything that you've written before. Every recipe has to be novel. And so, Kyle he's in trouble trying to implement this feature. So what do we need to do to try to help him? Well, we're going to redesign a database and the pipelines associated with it, right? So before we can help Kyle, what we have to do is sit down and just take a look at some of the key limitations that come into play so we know, will our solution actually work? Are we actually meeting the kind of goal that we want? So the first is going to be reliability. We have to make sure we have reliable outputs. What we have now is not going to be reliable, right? Because we have all of these trees. If we make one mistake in a key value pair, it's all gone. And it's all super dependent on each other, making sure that the recipes are done right and that they actually execute properly. Next, as you can tell, it's not easy to maintain because you have all of these independent recipes that you can never use again for a new component. So you've got to rewrite all of these recipes. And so it's hard to add new features, to debug, to even fix a bug, because everything is dependent on something else that's dependent on some combination of other components. Also, it's going to degrade the user experience because you're going to have longer load times because you have so much interdependencies in these hierarchies, as well as you're going to end up with broken data connections. And trying to extend this, because once again, this is not just for one classroom for just inside the US, it's the entire thing. This is a national program. So you're going to have new user needs as you move into other states. You have users coming from different places. And so it's going to be really hard to actually meet those users' needs. Also, because of the fact that you have an insufficient API in order to actually interact with this data, it's going to be hard to connect to other platforms or other platforms to connect to you. Performance is going to be really delayed retrieving data because you're not working with flat tables. Now you're working with a lot of hierarchy where everything is interdependent on one another. Scalability, you're going to once again have bottlenecks in your performance and user frustration because it's going to take a really long time to build out new features. It also poses a risk to user data and their confidentiality. And finally, this is just one big monolith, right? So trying to untangle it really hard, you can't really move it very easily. Everything has to go at once. All right, so time for our solution. So we know all of the different limitations that are there, what we're trying to do, we understand the problem. So what would a solution look like? So the first thing that we want to do is we got to migrate this thing to a fully relational database. Once we do that, we need to redesign the data pipelines and finish up by optimizing the backend for API integration, right? So those pretty reasonable. If we solve those things, then we'll be able to overcome the limitations that we currently have. All right, all done. If it were only that easy, right? So what we had to do was actually go in and figure out a plan for how do you solve this thing? You have a big monolith of a database that you can't pull any one part out very easily. Everything is dependent on something else. So the first thing you have to do to start this problem is retrieve the data. So what we did was use a Python package called ibis. And essentially what ibis does is it has a high-level interface for SQL as a data frame, okay? So it's great because it simplifies these complex queries and makes it programmable. So you can iterate and work through loops to try to pull out all of this information. It also is great at hierarchical data management, as well as it's in Python. So now you're out of having to do these very long SQL queries, which require many, many joins in order to just get it to work. And now you're in Python world. So now you have those tools at your disposal. Okay, so you have this, you run it, you're able to take all of that data and finally surface it up to the top. So what happens next? Now you need to design a brand new schema. Okay, so in order to do this, it's going to take a lot because this particular database had over 100 tables and right around 1,000 attributes, right? So that's not going to be easy to design a schema for. So in order to do that piece, we use what's called DBML or database markup language. Really useful. If you haven't used it before, I definitely say give it a look because it's lightweight, human readable, and it allows you to not only design your schema, but it automatically generates the documentation for you with it, right? One of the key features here that made it even more useful is that it's integrated with visual tools. So if you take a look over to my right, your left, you'll see these are the actual tables that were there. It is a monstrous amount, right? But I was able to visualize it and work through, figure out primary keys, figure out what's nullable, what's not, so on and so forth, right? So it made it visual, easier to work through, and now it's a little bit more manageable to figure out of all of these tables and attributes, how do they actually need to connect in a real relational type of way? Okay, so we've gotten the data, it's risen to the top, got a new schema, figured out how we can get the schema to work. So next, before we put it anywhere, we need to validate. We need to make sure that what they had is going to match what we expect to come in, right? And so we use two tools to do that. And the first one being Pedantic, which my colleague Don had mentioned. It's great for data validation. If you have not used it, highly recommend it because not only does it do data validation for Python types, it also does type coercion. So let's say that somehow inside of the database that you were expecting an int, but it's actually a string. Well, you can coerce it into the int using Pedantic. It also has excellent error reporting because what it allows you to do is say, okay, where did it go wrong? Well, it tells you. It doesn't just yell at you. It actually gives you a really useful set of reporting tools, so you can actually backtrace where did the issue come as I'm doing these migrations. Okay, so Pedantic is super useful, but this only handles data. But what about the actual SQL and relationship management? So that's actually where SQL Alchemy comes in. So SQL Alchemy is a toolkit, and it's specifically meant for relationship management within the context of SQL. It's great because it offers query flexibility. So it allows you to work at both a high level and a low level based on the granularity of control you need over the types of SQL databases you're trying to create. All right, as well as this declarative syntax. All right, so what have we done? We got all the data, rose it to the top, created a new schema that is fully relational. Now we know that we can come in, we can validate the data, we can validate the relationships. But I wish that there was something that could work a little bit better rather than having to do the data separately than the relationships to actually migrate the data. Well, there is. It's something called SQL Model. So this is a Python package that literally combines the features of SQL Alchemy with Pedantic. And what it does is it allows you to create these models that not only validate the data, also do all of your relationship management. And because of the fact that it's created by the same team that's at Fast API, it's also future ready for API development. So these same models that you use, you could import these, then write Fast API on top of it, and now the API is ready. All right. So we've gone from a mess to risen the data to the top. Then we've gone in, we've validated it, created a new schema, and now we have a way to actually migrate all the data into the new database. All right. So wonderful. We've helped Kyle, right? So what does this actually mean in terms of a broader impact? Like we've helped Kyle, and that's one person, but maybe we can do a little bit more with what we're trying to accomplish here. So the first one would be helping educators, because they'll have a better experience, right? They get features faster. They're able to get connected to coaches more easily. They're able to actually work with the platform better, right? So they're going to be kind of like the very first people that you're going to be able to help when this was completed. Next, you have the larger educational systems, which is going to be helpful because you have all of these decision makers, and now they're able to make data-driven decisions about how to better run classrooms, what kind of supports do teachers need, things like that, as well as to be able to have a scalable foundation for future ed tech. Of course, it's all about the kids, right? So we're going to offer a better quality experience for the children because now they have teachers who are better trained, who've been coached, who've been able to have more of these features and things that they need available to them. So they're able to receive more of the support that they need. And then finally, it would be nothing without also having some tech in there as well. So one of the great benefits is the ability to actually integrate with advanced analytics and reporting tools now, right? So we're not just siloed into the Coaching Companion world. We can interact with other softwares that are available. And so if there's anything I wanted to leave you with, it's really transformative what these guys are doing, right? I was glad to be able to be a part of it and to be able to help get us to a place where we're now more scalable and maintainable and all of these things. But it really is going to be transformative in early childhood education. And so with that, I just wanted to say thank you to all the contributors. Dawn, for helping me out. It was a little bit of a rough go there for a minute trying to figure out some of the key value stuff that's there, but I really appreciate the SSEC team as well as all of the Cultivate Learning team and the support that they offered us as well. So with that, thank you, and you are welcome to scan the QR codes if you'd like to find out more about what we did.
Great story. Thank you so much. Are there any questions that, yeah?
Just one question, like how long did the whole process of like restructuring the data like take you?
The restructure process. So specifically for the restructuring piece, that took probably 4 weeks. just to get the entire database redesigned. It took almost 4 weeks to figure out all of the key pair stuff, right? So because everything was intertwined and it was so hierarchical, it's hard to actually surface everything up to the top to then get started because you can't do anything else without it. So it's about 4 weeks for the first piece, and then actually working through all, 1,000 attributes and 100 tables took about a month to get through.
This is amazing work. Thanks for sharing it. I'm really interested about like the future life cycle, I guess, for both of you. What are your thoughts about how this software evolves? And, for example, in the database, is there going to be a need for other data sets to come in? And how will there be people who are trained in the new system who can work with it? And will there be like consultations, make sure that this continues to live on in the future?
Gotcha. So I'll say for this particular project, there will be some continued support to help because they have some additional migrations they need to do, but this is kind of like the foundation for all of it to occur. But this piece is going to be accompanied with kind of a redone front end as well. So because now the data is going to surface in a different way, that's why the API is so important, because now they have the models, they can use the API for a brand new front end. And so they will be like talking to us in the process and kind of consulting with us with making sure that they understand all the basics. But anytime we do a handoff, we always make sure that there has to be a maintainer on that project who's dedicated to this piece. But we also make sure like, hey, if you need something, we leave extensive documentation, right? So that's where using the GitHub issues, GitHub discussions, like all of those pieces that can leave an artifact for what we did. So let's say there's a new maintainer who comes in, they can pick up and have a pretty quick understanding and onboarding to any of our projects.
Yeah, I mean, I think Cordero hit it all. I think we have at SSEC, our open sources are in our DNA, so we make sure all of our projects are open source and extensive documentation and having a maintainer and like basically setting them up so that there can be community around the software that we help out and build is definitely key to all of our work. And so yeah, that's how we can keep this going to the future.
Yeah, I was also curious about the user base for this particular product, like who's using it actively.
So for this, it's going to be really just I would say early childhood education professionals, but once again, it's going to be nationwide.
Mhm.
So not just in the state of Washington, anyone in the US who's in that area. So early childhood as well as early childhood special ed will be using this.
I think it's not limited to just teachers, it can be tutors as well. and
Yes.
People like that, yeah.
All right, I think that concludes our seminar for today. Thank you so much. If you are interested in our seminars, I think you know what needs to be done, like sign up for the seminars for the class. And hope to see some of you next year and next quarter.
You're welcome.
We'll be at eScience for a meetup after this if you're interested in learning more about the center, and we'll have snacks. It's on the 6th floor of the astronomy building.